Null hypothesis significance testing has been fundamental to statistics and science for about the last 100 years. Yet it is one of the most counterintuitive concepts for new stats students to comprehend. Let's take a stab at explaining what it is and why it is so critical to our scientific philosophy. In order to understand null hypotheses, it's imperative to understand that science is biased. But it's biased toward disbelief. What do I mean when I say that? Early in our scientific history, we hastily accepted new ideas without much thought. This is why many in the Middle Ages tried bloodletting or arsenic or mercury to try to treat the bubonic plague. It didn't work. Here's the problem with the historical approach. New ideas can be generated instantaneously. Scientific research takes time. This means that if we're trying to cure a new disease, we will always have more new ideas than researched ideas. So how should science think about new untested ideas? Historically, we simply accepted them. We also remember how that turned out, in many cases. What if science takes the opposite approach? Don't trust things until we know they are safe and helpful. Imagine visiting a doctor in a world where every doctor practices this skepticism perfectly. In this world, your doctor's advice would always be to give you the best researched, safest, most trusted treatment to date. One of those untested ideas might be a better treatment. It might also be quite harmful. We're making a choice to choose the best we have over a chance at something better. This approach works in other fields as well. This means that any new idea in any discipline has to clear two hurdles. First, overcome our skepticism. And second, beat the best we already have. So how does this relate to statistics? In statistics, when you see the word null, think nothing. Nothing interesting, nothing important, nothing to see. The null hypothesis is our default hypothesis. That's what we go in believing will happen. We start with this hypothesis because we assume most things don't work. This is the first hurdle that all new ideas must surpass. The null hypothesis is our skepticism. In statistics, the null hypothesis is denoted H sub 0. The alternative hypothesis, H sub 1, is the instance when we've surpassed our skepticism and we think we maybe have actually found something. If we were comparing two groups' mean scores, the null hypothesis would suggest that there is no difference between the means. The alternative hypothesis would say that there is a difference. If we were comparing the variances of two groups, the null hypothesis would say the variances are equal. The alternative hypothesis would say that they are different. If we're testing the effect of one variable on another, the null would say that the first variable does not have an impact on the outcome variable. The alternative would say that it does. Remember that the null hypothesis refers to our finding nothing new or interesting. We are intentionally biased toward this hypothesis, until evidence tells us not to be.